Hi everyone, this is a video continue from the previous video, integration of a rational function. Actually, previous video I have named the wrong title. Actually, need to be integration of a rational function, not logarithmic function. Yeah. All right. So I have this rational function 2 over x. To integrate this, you may take out the 2 and you need to integrate 1 over x with respect to x. To integrate 1 over x with respect to x, you get log x. This is a simple one, plus constant c. Question B, if you want to integrate, just take out the 3 and integrate 4x plus 1, 1 over 4x plus 1. Then you have a log 4x plus 1, plus c. Alright, this is the answer. And the question C, I can take out the 2 over 3 because 2 over 3 as a coefficient. Then you can say that this integrate the 1 over x minus 1. You integrate this, you have log x minus 1 plus constant c. And for the D, for the question D, you might need to use a substitution method. Because for the question D, you can see that up here is a linear, and down here is a quadratic function. So to integrate this function, we might need to use a substitution method. Represent the u as a x squared minus 1. Then you can get your du dx. Obtain your du dx, you have 2x. I can see that 2x is appear in my question. So 2x dx, it can be substituted as a du later on. You can see the 2x here combined with the dx later on. I'm going to replace it by the du, yeah, from here. Then now we can start to write it down all in terms of u. I got my du, I just write down the du at the end of the integral. And this is a 1 over x squared minus 1. It's going to be the 1 over u. So I end up, I have integrate 1 over u with respect to u. I got my log u. Don't forget to plus a constant c. The u will be replaced back by x squared minus 1. So this is my answer. Proceed to the question E. We have integrate ex over 1 plus ex. Okay. So for this question, we have to use the substitution method too, because this is up here. If I let the u, if I represent the u as a 1 plus ex, I got my du dx as ex. Okay, because you differentiate u, you get 0. Differentiate ex, you get ex. Okay, so then you can see that the ex combined with the dx, it can be replaced by the du. Okay, then now this is going to be du, and the question, my question will become like this, 1 over u, because 1 over 1 plus ex is going to be replaced by 1 over u, and the ex ds is going to be du. Then we integrate 1 over u with respect to u, you get log u, yeah, plus constant c. And the u need to be replaced back by the 1 plus ex, yeah, plus c. Alright, this answer. And bear in mind that this is not a rational function, because rational function, both numerator and denominator has to be polynomial. I have this is a example is after you have integrated, it will produce the log. All right. So I include this example to let you see substitution method. We can use substitution method to integrate those functions in the fraction, which is appear the numerator and denominator. And the answer is in the log form. For the 3f, we have another rational function, where up here I have a constant and down here I got a linear function. For this type of question, it's simple. We just directly use a formula. Let's take out the 2 first. I have integrate 1 over 1 minus 3x dx. Then to integrate this function, we just apply formula, integrate 1 over ax plus b. With respect to x, we have a log ax plus b over a. Yeah, this is the formula. So apply this formula as your a is -3 and the b is +1. So when you integrate, you just put the linear function at the denominator, put in your log, put into the log, okay, and then over the coefficient of the x, that is -3, plus constancy, and just simplified it, you have a -2 over 3 log 1 minus 3x plus c. Yeah. Here is another example. Consists of six questions. You need to integrate the first one. You need to integrate ex over ex plus 2. And here in the question already state you must use the substitution method. Again, for the question A, it's not a rational function. Okay, but we know that I know that the final answer will be in terms of log. Let's try out this question. We have a ex over ex plus 2. Okay, for this question, we're going to apply substitution method. Replace the u as a ex plus 2. And followed by your du dx, you have your ex. Then you might see that your ex, the ex dx here, it can be replaced by du. See or not? You bring the dx up, you have the du at the left. So it means that the ex dx later on is going to be du. And 1 over ex plus 2 is going to be 1 over u. Write down 1 over u. And this is your du. You have 1 over u with respect to u. So integrate this, you have a log u, yeah, plus c. Substitute back the u as your ex plus 2. You have your answer, log ex plus 2 plus c. For this question, we also will apply the u as 1 plus e2x. Because why? Because when we find the du dx, we got 2e2x. So you can see that the e2x is appear in our question. So we might substitute the e2x in terms of du. Let's try out. Find the u. We let the u equals to 1 plus e2x. And du dx is going to be 2e2x. Okay? So the e2x here, combined with the dx, see or not? e2x combined with the dx. I bring up the dx. It can be substituted as a du over 2 later on. Alright, this can be replaced by du over 2. And 1 over 1 plus e2x is going to be 1 over u. Okay, so we have set the u to be 1 plus e2x. Then this is going to be du over 2. The over 2, I'm not going to write it down here. I will bring out the 1 over 2 as a coefficient. Then now we're going to integrate 1 over u with respect to u. Again, you get log u. Don't forget to plus constancy. And the u, you need to replace back by 1 plus e2x. Alright, plus constancy. Alright, this is a simple one. Just take out the 2. 1 over 1 minus 8t with respect to t. Then write it down the coefficient. Integrate this, just follow the formula. You get log 1 minus 8t over -8 plus c. Then we can simplify this. You get -1 over 4 log 1 minus 8t plus c. Just like that. Alright, this is the direct using the formula. But now the question said, using the substitution method, means that they ask us to use substitution method to answer this question. It's okay, we just let u equals to 1 minus 8t. And du dt will be -8. This means that your dt later on is going to be replaced by du over -8. So our question is 2 over 1 minus 8t with respect to t. 2 you can always bring out. You have 1 over 1 minus 8t with respect to t. And later on, the dt here, later on is going to be du over negative 8. And this is going to be 1 over u. Alright, because the question just asks us to use substitution method. Instead of using formula, we need to substitute we need to integrate by substitution. Okay, then alright, this one will be 1 over u. Alright, this one will be 1 over u. dt is going to be du over 8 over negative 8. And negative 8 again I bring out as coefficient. And this can be simplified to be negative 1 over 4. Integrate 1 over u with respect to u, you get log u plus constant c. Then simplify further, you have negative 1 over 4 log u is going to be 1 minus 8t plus c. So let's check the answer. This is the method of using substitution, and the method that I use the formula also producing the same answer. See, compare the answer by using formula, and this is the answer by using the substitution. Both get the same answer. For this question, we need to use a substitution method. There is no way for us to use a formula. Let's take out the negative 3. We have x on top. 2x squared plus 3, yeah, at the denominator. Let u equals to the denominator, 2x squared plus 3. Then you have your du dx as 4x. You can see that the x and dx here, we need to find the x dx in terms of du. To find your x dx in terms of du in this statement, x, you bring up the dx, you have x dx. Meaning that this can be replaced by du over 4. X dx, later on, I'm going to replace it by du over 4. So you can actually write down everything in terms of u. Negative 3, just copy down. 1 over 2x squared plus 3, it can be 1 over u. And this is the du over 4. Again, over 4, I'm not going to put it down here. I will bring out of the integral to be the coefficient, part of the coefficient. So now my coefficient become a negative 3 over 4. Integrate 1 over u, you have log u here, plus constant c. Then substitute back the u as a 2x squared plus 3 plus c. The same question, similar question to the question that I showed just now. Take out the 3. You have x over x squared plus 5. Alright, let's try to guess what u you will use. You can pause the video and try out the question first. Alright, let's check your answer. Is it correct or not? Let u equals to x squared plus 5. Get your du dx equals to 2x. And you might need to find the x dx from this statement so that it can be replaced by in terms of du. Okay, so if I bring out the x, bring out the dx here, bring up the dx to the right, and bring down the 2 to the left, I have my x dx equals to du over 2. This means that this is later on can be du over 2. And 1 over x squared plus 5 is going to replace by 1 over u. So everything can write down in terms of u now. You have 1 over u, du over 2. Again, the 2 I bring out as coefficient. So we got 3 over 2 outside. And integrate 1 over u with respect to u. Definitely you will get log u plus c. And finally, you need to replace back the u as your x squared plus 5. That's it. Then for this question, we have a quadratic on top, and down here we have cubic function. So this is a rational function that we need to use a substitution method to integrate. Firstly, we let u equals to 5 plus x cubed. Then du dx followed by du dx, you can see that you have a 2x squared. So here, once you get x squared, you can relate to your question. The x squared appear in our question. So we can actually foresee that the x squared combined with the dx, it can be substituted in terms of du. Alright, so we just bring up the dx, this is x squared, just copy down and bring up the dx to the right, and the 2 you bring to the left, you have du over 2, meaning that the x squared dx later on, I'm going to write it as a du over 2. 1 over 5 plus s cubed, this is going to be 1 over u. So now we have a 1 over u, integrate du, we're over 2. Over 2 I bring out as a coefficient. So copy down the coefficient, integrate 1 over u, with respect to u, you have a log u. And the final answer, you should write it back in terms of x. That will be log 5 plus s cubed plus c. For this question, we need to let the u equals to log x. Why we're going to do this? Because du dx, you're going to have 1 over x. Then after you have 1 over x, you can see that the 1 over x is actually appear in our question. So here, it gives you the hints that 1 over x, if you combine with the dx or you bring up the dx, you can make it in terms of du. 1 over x dx can be written as a du. Means that in your question, we have 1 over x, right? It combined with the dx, these two combined together, it can be replaced by du. And now everything can be written in the in terms of x, where the 1 over x dx will be in terms of du, and 1 over log x, this is 1 over log x, will be replaced by 1 over u. Means that now we just need to integrate 1 over u with respect to u, which you will have a log u plus constant c. Where the u need to be written back as a log x, so you have a log of a log x plus c. This is your answer. For this question, you have a cubic function on top and a quartic function, okay, at the denominator. So what we can do is you can let the u, replace the u as a x power of 4 plus 8x minus 2. Differentiate u with respect to x, you have a 4x cubed plus 8. After you have du dx, you may think that 4x cubed plus 8 you can't find in the question. But if you take out the 2, if you take out the 4, factor out the 4, if you factor out the 4, because 4 is a common factor between these two terms, factor out the 4, you may see the x cubed plus 2, which is appear in your question, x cubed plus 2. So you can say that the x cubed plus 2 combined with the dx, it can be replaced in terms of du. Let's see how. X cubed plus 2, I bring up the dx, I put it here. And the 4 I bring to the left, I have du over 4. Meaning that the x cubed plus 2 dx, in my question, I can replace it by du over 4. And 1 over x power of 4 plus 8x minus 2, it can be replaced as a 1 over u. Now everything can be written in terms of u. I have 1 over u, where this 1 over u replacing this 1 over x power of 4 plus 8x minus 2. And this is going to be replaced by du over 4. The over 4, I'm going to put it out and put it as coefficient. Now I have 1 over 4. Integrate u, 1 over u with respect to u, you have a log u plus c. Then final answer, we should replace back the u as x power of 4 plus 8x minus 2 plus c. That's it. Thank you for watching the video. For my next video, I'm going to talk about a tutorial on integration of a three-goal function. Thank you.